So let's go back to our Tic-Tac-Toe script, and so when we're about to switch turns, this is a good place to check if there's a winner. So we're going to do that. So I'm going to create another function. I'm going to call it update board state. And we're going to be calling this function inside switch turns, so I'm going to call it now. And make sure you do it before you switch players, because inside update board states, we may want to say who the winner is, and if we've switched the player already, then the winner will be the opposite player that we want, which is, exactly what we don't want. So let's not do that. So update board state. So in this board state, we're going to create a list of int objects, and this is basically going to be the current state of the board. I'm just going to instantiate it as a new list. So what I mean by the current state of the board is, for our statuses, we made sure they were 0, 1, or 2. And if you think of the board as a 3x3 grid, then if you think of it like an index, the first 3 columns are 0, 1, 2, then 3, 4, 5, then 6, 7, 8. So if we're thinking of it that way, we can use a list to get the values in each of the buttons, get the status values, and then use those status values to check if there's a winner, or to check the game state. So what I'm going to do is I'm just going to also have a bool see if there's a winner. And when this is true, we just want to immediately return out of the script, because if we find a winner, obviously there can only be one winner in Tic-Tac-Toe, so there is no point to continue looking. So when it equals true, we're just going to return. So now I'm going to set up the state, and to do that I'm going to need to loop through all of the board button toots that we created. Let's call this board button in board buttons. So if you remember, board buttons is an array of board button toot objects. So we're going to loop through each of those, and we're basically just going to add them to the state, or at least add their status to the state. So board button dot status. And that's all we need to do to create our state. That's how we create our board state. And we know whether all the buttons are a 0, 1, or 2. Okay, and then now we're going to loop through that state that we have. And make sure to loop using an integer loop like I, rather than a for each loop, because we need to know the current index that we're on. So we're going to loop through our state, and we're basically going to set the winner equal to the value in our state. Actually, we don't have this variable yet. Let's create it. So this int winner is basically which player is the winner. It's basically our current player. Maybe I shouldn't even call it winner. Let's call it cur player. So based on this button, on the status of the button, it's basically who owns this button, who has selected this specific button. So cur player equals state I, and so whose button is this, is what this current player is. And then now we're going to call when equals, and here's where we would have some check to see, based on this button, if there is a winner. We haven't written that function yet. That's going to be a separate function. So let's go ahead and do that now. So I'm going to create a new function called check for win, or check for winner. It's going to take in the state, the whole state, and then it's just going to take in the index that we're currently at, the index of the button we're currently at. So that's just an integer index. Okay. Oh, and state is not an integer. State is a list of integers. There we go. Okay. So this is where we get into the logic behind Tic-Tac-Toe and how we know if there's a winner. So here, I'll write it out a little bit. The way we know if there's a winner in Tic-Tac-Toe is 3 in a row, and this can be horizontal, vertical, and diagonal. Okay, so let's keep that in mind when we're doing this. Sorry about that. So one way to think of this, and this is how I did it, is I used mod. And if you aren't sure what mod is, you can look it up real quick. Let's look up mod calculator. So the reason why I want to use a mod is if I'm using each row is going to have a 0, 1, and 2 column. The first row 0, 1, 2, 3, 4, 5, 6, 7, 8. But I want each row, I want their values to be the same column-wise. So I want them all to end up as 0, 1, 2. So how do I turn 4, 5, 6 into 0, 1, 2? And how do I turn 3, 4, 5 into 0, 1, 2, and 4, 5, 6 into 0, 1, 2. So that instead of having 0, 1, 2, 3, 4, 5, 6, 7, 8, I have 0, 1, 2, 0, 1, 2, 0, 1, 2. This just makes it easier to calculate to see if anyone won on each row without having to change the indexes I'm looking for. So in order to get 0, 1, 2 for each row, if you mod with 3, so let's say I do 0 mod 3 to start, I get 0. Let's do 1 to mod, I get 1, and then 2 to mod, I get 2. And now I go back to 3, and I'm back at 0. So if I do this 8, for example, which is actually the 9th spot, because remember we're starting at index 0, I get 2. So this works. This gives you 0, 1, or 2, and I like it. So I'm going to use mod. So I'm going to have a mod value, which is basically this index mod 3. And then what I'm going to do is I'm going to grab that status of the state at my current index. Okay. And real quick, if the status is equal to 2, this means that this square hasn't been selected. Then it's impossible for there to be a win state from this square or from this tile. So we're just going to return out of this because there's no point for us to go any further. Oh, and actually this should be a bool because we want to know if there's a winner or not void. Okay. Next, we will want to check if there's a winner. And before we do that, we're just going to have some kind of holder bool to see if there's a winner or not. And then what we'll do is, if we're now going to go through each of these cases. So let's start with the case where, well, let's start with the first row. So the first row is 0, 1, 2. So the way we're going to make sure we're starting with the first row is we're going to check if our index is less than 3, because the first row is 0, 1, 2. So if we're starting it in the first row, we're going to need to check to see, we can set when to it, we need to check to see if, we'll start with checking to see if this square is equal to the square to its right, and then the square to the right of that. So if we're starting in the 0 index, if the 0 index state is equal to the 1 index state, and if that is equal to the 2 index state. So basically we're checking the entire row, just the row, to see if they're all equal to the same state, assuming that state or that status is not empty. So we would do state, and in this case this would be 0 plus, or sorry, we don't need to check 0 because that's our current state, so we actually just need to check the 1 state and see if that is equal to our status, our int status, and state 2 is equal to our status. Now, I don't want this to just, or we're going to be reusing this check a lot. And anytime you reuse something a lot, it's better to make a function out of it. So we're going to create a function that's going to be called status check, and it's going to take in the state because we need that. Oops, yeah, no, that's right. It's going to take in the base number, which is basically the index we're starting from, and then it's going to take in the offset for the first value and offset for the second value, and int status. So to make this, let me actually just copy this because it's going to be very similar. And instead of this 1, we're going to use the base num, and we're going to add an offset. And then in this case, we're going to use the base num again, and we're going to add offset 2. Okay, and then we basically just need to return what this returns, and that will tell us whether, so we have a current status, and we're checking to see if one square, one tile, at some offset is equal to the current status that we have, and if some other tile at some other second offset is also equal to the same status. So this is a nice little function to check 3 tiles to see if they're equal, which is basically what we're going to be doing a bunch, checking 3 tiles in different ways. So instead of this, we'll just call status check, and our state is our state, base num is our index, and the offset. So if index is less than 3, and we're just trying to check the first row to see if the first row is equal, we basically just need 0, or sorry, we just need 1 and 2. And then our status is our status. So if we think about this, this will be checking if the first row is a winning row, because we're just indexing by 1 from the current the current button's index. So let's say we're starting at 0. 0 is equal to, let's say, O. So 0 is equal to O. Then this 1 offset from 0 would be the first index position. Let's say that's O. And then we look here to see if the second offset, which is 2 from the first, from the original button, and we check to see if that's also 0 or O. And if all 3 of those are O, we know that the player has won. So then we could just do if win. So this is either true or false. It's true if we found a win scenario, it's false otherwise. So if win, we're just going to return win. We're just going, because we're trying to return a bool. If no one has won, we'll return false. Otherwise, we should return win immediately because we don't want it to get overwritten, and there's no reason to keep checking if someone has won. So this particular win state, we want it to actually happen for every row and not just the first row. So I'm actually going to move this out of here so that now it will check for every row. A scenario we only want to check in the first row are the diagonals. So let's do the diagonal for the 0 position. So let's do win equals state check. Or sorry, not state, status. State index. And then if we're thinking about the diagonals, it needs to be the 0 index from the top left corner tile. And then we want it to be the center tile, which would be in the third index, because 0, 1, 2, or sorry, fourth index. Fourth index. And then finally we want to check in the eighth index. Yeah, eighth index. That would be a diagonal in a diagonal from the 0 index position. So that's a win state we want to check, and we only want to check this in the first row because there's no point to recheck this diagonal in other rows. So we just want to check this in the first row. Because we could check this from, say, index 4. But what would be the point of that? Because if we've already checked it from index 1 or index 0, if it didn't happen in index 0, it won't happen in index 4. It doesn't matter. So we don't need to check this too often. So what else should we? Well, first let's do if win, return win. And then what else can we check here? We can check the other diagonal. And the other diagonal, actually, wait a second. This we only want to happen if index equals 0. And then this we only want to happen if index equals 2. Sorry, not when equals 2. Actually, let's go back a second. This we only want to happen if index equals 2. So we don't want to be using the state of, say, for example, the button in the one index position to check to see this, because this is the diagonal only for the 0 index, so that's why I had to add that index equals 0. And so now we're checking the other diagonal, which is from the right side to the left side down, and so that needs to be index 2. So, and then let's think about how much we're going to add to get that. We're starting at position 2, and we want to go to position 4 because that's the middle point. So that means we need to add 2, and then we want to go to position 6 because that's the bottom left. So that's adding 4. So, and then we need to make sure we add the status. And we'll check that for a win scenario. And then for everything else, we need to make sure we check vertically. So we've checked, let's start writing this out a little better. We've checked horizontally, each row, vertically, or this doesn't check vertically, just horizontally. And then these check diagonally. So now let's just check vertically. And vertical can be done with just the first index, or just the first 3 indexes. Because, once again, if I check if the 0 index, if the 0, 4, and 6 index, or sorry, 0, 3, and 6 index, if I check to see if that's a match, or that's a win scenario, that's the same thing if I'm starting from the 3 index and I check if 0 and 6 is a win state. So we only need to check it once from the top of the board to see if there's a win. So we're also going to put this in here. But we want this to happen for all indices in the first row. So we're not going to have some check to see if it's index equals 0, index equals 2, or we're just going to say win equals status check state, the current state, the current index, and if I add 3, so if you think about this real quick, if I'm on position 0 and I add 3, I'm at position 3, which is right below my current position. And then if I add 6 or 3 more from position 3, I get to position 6. And 0, 3, 6 is a column. Now let's do the same for index 1. If I'm at index 1 and I add 3, that's 4, which is the exact center of the board. And then if I add 3 more from 4, I get 7, which is below that. So, and that creates another column. So as long as I'm offsetting by 3 always, I will basically, well, 3 and 6, I will always be getting the row of whatever index I'm looking for. So 3, 6, and then status. So this is vertical checking. So we've got horizontal checking for a row, vertical checking for a column, and then these two are diagonals. And that should be all of our win states: diagonals, vertical, and horizontal. Horizontal, we do have to go every column, or sorry, every row, but we also need to make sure that we're only looking at where the mod is 0. So if mod, because we don't want to be trying to check a row when there's only 1 or 0 tiles to the right of it, because the whole point of our offset is to check all 3 tiles to the right, or all 2 tiles to the right of the object we're checking on, which always has to have a mod of 0. Okay, so this checks horizontally each row, we're checking vertically, and we're checking diagonals. That should be all the win states. If none of these return true, I quickly need to add these real quick so that this will return right away and not progress through the rest of the function if there's already a win state. None of these return true. We're just going to return win again, which will be false, which means there is no winner. Okay. And then you might be asking, well, how do we know who won? Since we haven't changed the games, since we haven't changed the current player, the player that won is always going to be the current player. And we will set that up when we call check for win. So we're going to call that inside our update board state. So from each of our state, or from each of our buttons, from each of our tiles in our board state, we want to check if there is a winner. So we're going to give it the state that we've already set up, and we're going to give it I, which is the index of whatever this button is that we're checking from. And we want to store whether this is true or not. Oops. And if at some point check for winner is true, there's no reason to continue to the other buttons. This is just a little optimized if you do it this way. So we might as well just break out of this for loop or even return, depending on what you want to do. In our case, we don't have something to do yet, but we should. So I think I'll just break for now. So this breaks out of this for loop, and then down here we're going to want to do something with when we have a winner. So I'm going to create function on win, and then for now it's just going to debug.log. We have a winner. The winner, oops, is, and then the winner is going to be the current player, but this is going to be 0, 1, or 2, which is not what we want, or sorry, 0 or 1. So instead of that, we want to, we'll do a quick, another one-line if statement. Current player equals 0, and we want O, else, X. Let me do this real quick. Oops, one more. Oh. And let's finish with the semicolon. There we go. So if the current player is 0, then we're going to add an O to this string. If the current player is 1, we're going to, or other else, which it can only be 1, we'll add an X to the string. So, and then we just need to call this function, and we need to call it here. So if win, oops, we need to call on win. So that's pretty much the entire game. Inside this on win function, you would want to add anything extra you want to happen when you win, you know, sound effects, display something on the screen for the player to know who won, restart the game, stuff like that. Okay, so I figured out what I did wrong. For some reason, I just put a break here instead of adding a check to see if the player won. So we'll fix that. So if win, then break. And then that calls on win, and let's see now. Okay, so great, we got a winner. You can see I can still play. To fix that, just so you guys know how to restart the game, I'm going to add another using scene management. Is for any type of scene control. And so after the game finishes, I'm going to debug this statement, and then I'm going to scene manager dot load scene manager dot get active scene dot name. So this will just reload this scene essentially. And so if I go back and clear that, play, I will win with O, and you can see it displayed who the winner is in the debug, and then it restarted the game. And I should be able to win. There we go, there was a diagonal win, O1. Let's have X win for once. There we go, X is the winner. So that's basically the entire thing. I hope you guys found that useful. Let me know if there's anything else you want me to make a tutorial for, and thanks for watching.